Can grade 5 students come up with math conjectures? Indeed, yes, they can. And your child also can. Welcome to Math Inquiry Based Learning Journey session by the Gym Foundation. This is Vidya Govindan. I'm going to share some interesting activities that I recently had with grade 5 students in the fractions concept, which promoted a kind of asking questions environment and then making them more curious, find patterns and make observations and enjoy the process of learning. So, in this process of learning, they also came up with conjectures, which is nothing but an educated guess based on their observations, and then which led to kind of prove them or disprove them with counterexamples. I'm going to share that activity and the framework we used and the approach we taken to all of you for you to kind of be part of this learning journey and make your own observations, conjectures, and go ahead with proving them. Welcome to the second episode on fascinating fractions. In this, we are going to see how grade 5 students are making interesting observations which led to mathematical conjectures on comparing unlike fractions. And that's also sparked a very interesting debate among the entire class group students, which come up with counter examples to disprove and also many examples to prove the conjecture. Please do watch the first episode where we discuss a lot about the over technique, which we apply as part of this learning process, which corresponds to observe, verify, examine, and reflect. So we started with the simple activity of taking a paper and then equal sized paper and then dividing it into four equal parts and dividing into six equal parts and then choosing three parts from both of them and then asking which paper has more colored parts and how do you find it. So we did not go directly telling how to find it. Instead, we help them provide some kind of framework which will help them come up with questions and then think and reinforce their previous learning and apply them so that they come up with new knowledge based on their previous knowledge. So in this case, what you need to find is basically which is bigger. Is it 3 by 4 or 3 by 6? And then what do I already know about comparing fractions? We already saw in the episode 1 how to compare like fractions and how to compare unit fractions. So children were sharing that like fraction comparisons are easy because you already know how many equal parts are there and how many parts you have selected. So you can just compare the numerators on that case. So in this case, they are not like fractions. So they started thinking, how do I make it as a like fractions? So for example, if there are two fractions like 3 by 8 and 9 by 12, how do I compare them? Because the denominator are different. They cannot compare because the number of equal parts in one whole are different. And then we had a discussion on how to make the denominator equal, if that is what you're looking for. Then one child came up with an idea, ma'am, maybe I can multiply 8 with 12 and then 12 with 8. So both of them are same now. Okay, so is it this enough or will the fraction value be same if I just multiply the denominator? And then came the discussion, no, I need to make it into equivalent fractions by multiplying the numerator also by 12 and denominator by 12. And in this case, numerator by 8 and denominator by 8. And then they are able to compare that 36 and here in this case it will be 72. Therefore, 9 by 12 is bigger. And in this case, they had a denominator of 96, and some children felt, okay, they are very big numbers. What happens if I have big numbers like this? We had a discussion of why was 96 easier for us because of having the same number between 8 and 12. And later we had a discussion about can there be some other numbers which are smaller than 96 but still which comes in both the tables of 8 and 12. And then children started telling, yeah, there are so many common multiples, right? And the lowest common multiple of 8 and 12 is 8 times 3 is 24 and 12 times 2 is 24. And they came up with an idea, okay, so I can just find the LCM of 8 and 12, which is basically 8 times 3 is 24, and then 3 3s are 9 to make it equal in fractions, and 12 times 2 is 24, and 9 2s are 18. So therefore, it is bigger. So both the values are same, and children actually try to understand that to make into like fractions they can just find the least common multiple of the denominators and then convert into equivalent fractions. So this is how they applied their previous knowledge and figured it out. And they took many examples, examined it, and concluded their observations are true. And the most interesting part of reflection, when they were asked to make observations and then ask wonder questions, of any crazy wonder questions, that would be a good starting point. So one child wrote, "Can we simplify the unlike fraction and compare them?" Very interesting question indeed. For children of primary, having bigger numbers and comparing them are always troublesome. So I asked them to come up with some examples, and she told, "Okay, come, let's number like 16 by 24 and 9 by 12. How do I compare them? Do I need to compare by taking the LCM and then comparing, or can I just simplify?" And then I asked her, "Come on, try, let's do in groups. One group will actually work it out with the LCM. In this case is 24, 16, and then 12 twos are 24, 9 twos are 18. And the other group came up with simplifying and then comparing. So in this case, 8 twos are 16, 8 threes are 24 when it is simplified, and 3 threes are 9 and 4 threes are 12. So now they have this 2 by 3 and 3 by 4, and the LCM of 4 and 3 is 12. So 3 times 4 is 12, and here it would be 2 times 4 is 8, and then 4 times 3 is 12, and 3 times 3 is 9. So this is bigger. So they actually made very wonderful comparisons that both these fractions are indeed equivalent fractions themselves. Like 8 to the 16, 12 to the 24, 9 to the 18, and 12 to the 24. So they understood that we can simplify the unlike fraction and compare, because when you simplify, it does the value. So that was the misconception. They were thinking that if we simplify, will the value change? No, the value will not change. But profound understanding they had. And there was one activity which discussion, 3 by 4 and 9 by 10. So when one child was providing the reasoning that why 3 by 4 and 9 by 10, 9 by 10 is bigger, ma'am. Why? Because 9 is bigger than 3 and 10 is 4. So 9 by 10 should be bigger than 3 by 4. And there were so many giggles around the class telling, how can you compare the numerators and denominators separately? Will it even work? And then the girl came up with very many interesting examples. Ma'am, it should hold true. For example, like 5 by 8 I'm taking, and then I'm taking by 10. Obviously, this should be big. And all the children worked out and they found 7 by 10 is bigger. And so she kind of framed a statement telling, if the numerator of the first fraction is bigger than the numerator of the second fraction, and numerator of the denominator of the first fraction is greater than the denominator of the second fraction, then it is sure. I need not compare, ma'am. I can just say that the first fraction is bigger. Oh, the whole class was stumped. So actually, some children were telling this may not be true because always, like it is not an always true scenario. Maybe it is sometimes true. So for those children, I asked them to come up with a counter example. Can you give me a counter example which adheres to this conjecture that she made, and also prove that it is not so? And another group said, "Ma'am, it is always true." And then I asked them, "Come on, if it is always true, can you try with different examples and check if it is always true? What kind of different number fractions you will take? And then also check it out if you can prove it somehow." And the first group of counter example came up with a wonderful example of comparing 2 and 3 by 4. So basically 2 by 3 and 3 by 5. So they came up with 2 by 3 and 3 by 5. So let's apply the LCM and see if it is 15 is the LCM, and 3 times 5 is 15, 2 times 5 is 10, and 5 times 3 is 15, and 3 times 3 is 9. Oh, so in this case, as per this conjecture, 3 by 5 should be bigger, but it isn't. 10 by 15 is bigger, which means 2 by 3 is bigger. And the entire class got shocked. Okay, so somehow the conjecture kind of did not work. So basically this was disproved, and there was a good debate on that, how it got disproved with a counter example. And then the girl who actually came up with this conjecture, she observed for a moment and told, "Ma'am, I think I need to slightly change the conjecture that I should have the numerator added with the number, increased by a number. It should be the same increase on the denominator also. Like for example, if there is 2 by 3 and 2 plus 1 is 3, and then 3 plus 1 is 4. So what she basically says is, when the numerator of a number, let's say for example, let's take 3, any number 3 by 8, and then if I have to come up with another fraction which is bigger, I can add any number to it, like 3 plus 4, but I should add the same number to the denominator. So then it will be 7 by 12. So she told for sure that this conjecture of, when I actually add to the numerator and denominator, then the resulting fraction will always be bigger. And then the class was having entire discussion which is going on to come up with counter example to kind of tell that this will not work in some cases. And they are still yet to find a counter example. And the other group and the girl which actually was discussing about this conjecture, she also came up with a task of proving why her conjecture works. And her conjecture is, if the numerator of a fraction is bigger than the numerator of a second fraction by some number, and the denominator of the first fraction is bigger than the denominator of the second fraction with the same number, then the first fraction should be bigger. It's up to you now to either disprove it with a counterexample or prove it with a interesting proof. Stay tuned for the third episode where we are going to see how this kind of approach towards learning creates new knowledge base to generate new ideas, and also kind of come up with examples and counterexamples, and which will also help them clear their misconceptions. Stay tuned for the third episode to see how these kind of examples brought new observations and interesting aspects of comparing fractions. Thank you.